Developing a system at CMS can be very challenging due to complexity in accessing the necessary data. Portfolio Data Storage and Services is a proposed framework that will help CMS maintain fewer data assets, maximize the business value of each data asset, and make these data assets easy to find and reuse.
Hello, this is John.
Hi, John. This is Ben from Operations. I hear you have some data that we could really use. Can you provide me with a service that allows me to get access?
I would love to, but right now I don't have the resources to satisfy your request. If you can give us some funding, we should be able to provide you with something.
That would be great. How soon can you get it ready?
In about 3 months, depending on other priorities.
In 3 months? I can't wait that long. We're in the middle of an agile sprint, and that data is critical to the agile time frame. I have a better idea. Can you give me a copy of the data? Then we will develop the services ourselves.
I guess that if we aren't able to meet your schedule, the next best thing is to provide you with a data extract.
Working with extracts is not a preferred approach, but in cases like this, it is a serviceable method to satisfy the request with minimum time and cost. System A's manager convenes a small group of staff members to configure the request according to System X's requirements. The extraction is executed by pulling the requested data from the database and transforming it into the requested format. The extract is packaged up and delivered to System X. Despite the simplicity, this data extraction incurs a cost to System A. System X must take steps to make their copy of System A's data usable. Once a local storage location is found, analysts assess the data to survey the structure and perform quality assurance. Finally, programmers will build transformation and loading code to integrate the data into their environment. Consuming System A's data also incurs costs to System X. It is infrequent that the data transformation and loading are done without a hitch.
Getting this extract means we're not dependent on System A. Now that we have profiled these columns, we can develop the ETL code. Uh-oh. What we loaded looks like it has some errors and inconsistencies. Let's review the data again. Our review indicates that we don't really understand what some of these columns mean. Let's check this out.
Hi, how's that data set working out for you?
We have hit a few snags. Can we schedule a meeting to discuss the data?
Sure, how about early next week?
I guess if we can't meet earlier. These issues are creating delays, which I need to explain at the next stand-up meeting. And we also need a way to keep up with any changes in the data since the last extract.
Either we can set up a change data capture so that you can get our updates, or we can generate a new extract on a periodic basis so that you can get the updates batched up.
A regular extract would be great, even if we have to figure out the updates and track the history on our own. How often can you produce that extract?
If you can provide the funding, we can do it on a weekly basis.
We hadn't really budgeted for that, but I guess I will find the money somehow.
Once it becomes known that a system owner is able to extract data for one customer, other customers may soon follow. An increasing load of data extract requests may not only become a burden to the system owner, it also allows delays to pile up in delivering the extracts to each of the customers. This approach has a number of issues that impede the quality and speed of system development, including need for additional computing resources to support the extract demand, increased storage costs for multiple copies of the data, synchronization and data currency issues, leading to potential inconsistency, additional resource costs, lack of data domain knowledge, lack of support for agile timelines. To address these issues, we must rethink the way we handle the important enterprise data assets that should be shared across the organization. We must consider a different approach that increases access to source data where possible, decreases the need for making numerous copies of the same data, reduces the continued demand for source system resources by separating storage from computation, and limits the amount of domain knowledge required to utilize the data. We propose an architectural approach called Portfolio Data Storage and Services, or PDSS, which describes environments for managing, sharing, and reusing the critical data assets that are in high demand. The goals of PDSS are to standardize data models for shared data domains, define a common vocabulary, harmonize data element meanings, and ensure data consistency across different contexts and processes. These standards allow the data to be stored in a standard format in a cloud-based repository and to be produced in a variety of output formats as needed. The PDSS architecture is engineered so that different source systems that create or manage data from a common data domain can contribute their data to a shared PDSS object store. Contributed data are subjected to a collection of data curation processes, which, among other things, validate compliance to defined data standards, monitor data quality, and ensure that the data set can be integrated with the repository. Once those criteria are met, the contributed data are transformed and integrated into the shared repository. Even though different source systems may contribute data, PDSS systems enforce synchronization of the data to prevent the appearance of data inconsistencies. This way, data consumers can be confident that they are accessing the most current, highest quality data from the PDSS repository. As opposed to a traditional system architecture in which the computing engine and the storage environments are tightly coupled, PDSS is based on a storage architecture that is separate from the computing resources. This allows storage resources to be scaled independently of computing needs. Since PDSS is deployed using cloud-based data storage, data consumers have the full palette of associated cloud computing services at their discretion. Project teams wishing to consume data stored in a PDSS repository are able to bring their own computing resources to the table. Teams that use their own computing resources have much greater control in managing their budgets and their project timelines in support of agile development. Source systems may contribute different types of data assets into a PDSS repository, including curated master data, curated data products, as well as uncurated data sets. Data access should not become more complicated as more data assets are added to a PDSS environment. Making data available means providing services that are used for consumers to access the data. A curated dataset's primary data owner, supported by the joint product owners, will create and publish lightweight services such as search and retrieve or creating a new shared record. More complex services and APIs may be developed by the data consumers. To simplify data access, a PDSS environment will provide a data and services catalog. This catalog documents relevant information about each data asset, including a description of the dataset contents, source and lineage data, and methods of accessing and using the data. The Data and Services Catalog will also document details about available data services, their interface specifications, and guidelines for integration into data consumer applications. A data consumer consults the Data and Services Catalog to find the desired dataset as well as any services that can be used to access that data. Because PDSS has separated storage management from tightly coupled computation systems, any system that wants to access the data can launch the service using its own compute resources. If the data consumer's needs are not met by existing services, that consumer can develop its own services to access and process the data. In turn, that data consumer can contribute its new services into the inventory of services and register them in the Data and Services Catalog. That makes the new services available for others to use. The PDSS architecture will also provide system services designed to synchronize data contributions and ensure that there is a consistent view of the sequence of repository updates. Consuming systems can subscribe to the PDSS domain so that they will be alerted to published updates that can be propagated from the PDSS repository in real or in near real time. Requested data can be produced in a variety of formats, such as XML, JSON, or RDF, depending on data consumer needs. The PDSS architecture addresses the challenges of the existing environment. There is no longer a need for multiple copies of the data because each customer can access the data on demand using their own compute resources and develop services. PDSS architecture enforces synchronization so everyone sees a consistent view. The owners of the source systems no longer need to cover additional costs for data extraction, since the customers are free to develop the services they need or make use of existing services. Because the data is synchronized, there should not be a data currency issue. Allowing customers to access the data more quickly supports the Agile development methodology. The Data and Services Catalog contains all the information necessary to find and access the desired data sets. Transitioning to a cloud-based environment based on the PDSS architecture provides an evolutionary path for enterprise system renovation. As PDSS adoption increases, overall enterprise data management costs will decrease, while the simplified methods for data sharing and reuse will dovetail nicely with the Agile development methodology.